Today we shall learn about a very special three-dimensional figure, that is frustum of a cone. You have not learnt about this one in the earlier classes. Now as you can see, the frustum of a cone, that means the frustum is derived from a cone. To understand this one, let's take an example of a cone. So this is the base of the cone and this is the vertex. So this is my cone. This is a circular surface, so this is a radius r. This is my height h and this is my slant height l, and of course this angle is 90 because it is a right circular cone. Okay, now imagine if I cut this cone with a plane parallel to the base like this, cut somewhere like this. So what will I have? I will be left with something of this sort. The base will be there. Here another base will be created because I have cut the vertex, isn't it? So I'll have a figure of this sort. This figure is called the frustum of a cone. Here, as I have two bases now, this is a larger base, so this radius will be called capital R and this radius will be called small r. The distance between them is of course your height of the frustum, and this is your L, slant height. Okay, so this is the figure of a frustum, and obviously this is derived from a cone. Alright, now let's try to learn the formulas for CSA, TSA and volume of the frustum. Let me redraw the frustum again. So I have a larger circular base, I have a smaller circular base and something like this. Okay, this is my capital R, this is my small r, this is my height h and this is my slant height L. So the CSA, the curved surface area of the frustum, that means only the curved surface. That means if I draw the frustum somewhere here for your understanding, your CSA means this part, right? So your CSA is pi into r plus r into L. What is L? Slant height. Alright. My TSA, when you talk about TSA, of course you have to take care of the curved surface, that means pi into r plus r into L is already there, plus this circle which will be pi smaller square plus this circle which will be pi capital R square. So this is my TSA, and of course finally the volume of a frustum is 1 by 3 into pi into h, that is the height, inside bracket r square plus smaller square plus capital R smaller. Alright, so the formula for CSA, TSA and volume. And slant height, for cone the slant height is square root of r square plus h square, but for the frustum this will be very interesting, this will be h square plus, because there are two radii, so r minus r whole square. Alright, so these are all the formulas. Typical examples of frustums are, obviously you can imagine, the glass that is at your home, or the bucket that is also at your home. The glass and buckets are the examples of frustum. Alright, so we have discussed all the three-dimensional figures. From the next video onwards we shall start solving the questions from the exercise.